Hi students, in this video I'll be going through a couple of questions on trigonometric ratios. Alright, so let's take a look at the first question. So in triangle ABC, AB equals to 9.6, BAC equals to 90, and angle ABC um, equals to 52 degrees. Alright, so we are given these values. H lies on BC such that AH is perpendicular to BC. So this means that angle AHC is also 90. Alright, so in part A, we are asked to find the length of AH. Okay, AH, so is this a vertical line, blue line over here? Okay, for this particular topic, you need to identify where are the right angle triangles. So in this case, for part A, AH is part of the right angle triangle ABH. Okay, so we will focus on that triangle. Right, so for this topic, it's important to know the trigo ratios, 𝐓𝐫𝐢𝐠𝐨𝐧𝐨𝐦𝐞𝐭𝐫𝐲. So tangent is opposite over adjacent, cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. Alright, so we have our 𝐓𝐫𝐢𝐠𝐨 over here. Okay, so for part A, we will focus on triangle ABH. Okay, why do we do so? Because we know length 9.6, we know the angle 52, and this is a right angle triangle. So we will be able to apply trigo ratio to find AH. Okay, the angle that we are interested in is over here, the 52 degrees. Okay, so now we can label the sides. So this 9.6 that we know is the hypotenuse, and AH that we want to find is the opposite side. Okay, so now you see, you look at the three trigo ratio, which one involve O and H? So you can clearly see that it's sine. Okay, so now we know that what we need to do is to use the sine trigo ratio. Alright, so sine 52 degrees equals to O over H. So O is the AH that we want to find, and H is the 9.6, okay, 9.6. Okay, so from here we will be able to calculate AH. So AH will be 9.6 sine 52 degrees. Alright, so 9.6 sine 52. Sine 52. Okay, so make sure your calculator is in the degree mode. Okay, so you should get 7.5649. Okay, so remember to write a few more significant figures. So usually 5 sig fig will be good before you round off the final answer to 3 sig fig. Alright. Okay, so this answer is the one that you want to input into the answer space. Right, let's take a look at part B. Okay, so part B we want to find the length BC. Alright, so BC. Okay, so BC is this entire length over here. Okay, this is where you will need to shift your focus, because BC is the hypotenuse of the big triangle, right? ABC. So you need to shift your focus to triangle ABC. Okay, so same thing, we have our angle 52 degrees here. We have 9.6. But now this 9.6 is no longer the hypotenuse already. Okay, because if you focus on the big triangle, okay, and the angle that we are interested in is the 52, this 9.6 actually becomes the A already. Okay, so now let me maybe trace out this triangle. So we are focused on this triangle, okay, this one. Okay, we are interested in this one. Okay, this triangle. Okay, so this triangle over here. Okay, so the angle 52 is here, the right angle is over here, angle A. So BC is actually the hypotenuse. Okay, so we have A, we want to find H. Okay, so which trigo ratio do we use? Okay, we will use cosine now, right? Okay, maybe I'll write the working for part B over here. Okay, so now we will use cosine. So cosine 52 degrees is A over H. So 9.6 over BC. All right. Okay, so if on the right we have divide by BC. So if we bring BC to the other side, it will be like that. Okay, BC times cosine 52 is equals to 9.6. And now we bring the cosine back down. Okay, times on the left side. You go to the right side, becomes divide. Right, so let's calculate now. 9.6 divided by cosine 52. Okay, so I'll get 15.593. Okay. Okay, so if we round off to 3 sig fig, it will be 15.6 cm. Okay, 3 sig fig. Right, so this will be the answer. Okay, so always identify the right angle triangle. Uh, find the angle that we are interested in and then label the sides. And then after that, you'll see which trigo ratio can be applied to solve that question. All right. Okay, let's take a look at question 5. Okay, so in triangle DEG, DE is 15.3, DG is 6.9. F lies on the line EG such that angle DFE is equals to 1 to 6. All right, so now we're going to find the part 1, find EG. Okay, so EG is a part of a side in the big triangle. Okay, and this is a right angle triangle. Okay, then we have two sides, ED and DG. Okay, so whenever you have two sides of a right angle triangle and you want to find the third side, we are going to use Pythagoras theorem. Okay, so using Pythagoras theorem. Okay, so a lot of questions will involve a combination of Pythagoras theorem and trigo ratio because these two concepts are pertaining to right angle triangle. Okay, for triangle DEG. Okay, so we will have EG. Okay, the sum of the squares of the two shorter sides, okay, equals to the square of the longer side, the hypotenuse. Okay, so EG square 15.3 square minus 6.9 square. Okay, let's calculate. 15.3 square minus 6.9 square. Okay, so I got 186.48. Okay, so EG will be square root of 186.48. So square root. Okay, so I will get 13.656. So I round off to 13.7. All right, cm 366. Okay, so we are done. Okay, so the next part of the question, they want us to find FG. So FG is a side in the smaller triangle DFG. Okay, we already know one side is 6.9. We know there's a right angle triangle. Do we know any other info? Okay, so you may think the answer is no, but actually we can find this angle easily. Okay, so we should try to find it and then we see how we can make use of it. Angle DFG equals to 180 minus 126. Okay, so that will give me 54 degrees. Okay, so this is 54. So now we have an angle, we have a side, and we know it's a right angle triangle. We can use trigo ratio. Okay, so now the triangle that we are interested in is DFG. The angle we have is 54. So FG, the side that we want to find, is the adjacent side. And then this 6.9 that we have is the opposite side. So once again, which trigo ratio involve opposite and adjacent? So it's tangent. Okay, so that's what we are going to use. So tangent 54 equals to opposite over adjacent FG. Okay, okay, so FG will be 6.9 over tangent 54. Okay, so go and calculate. Let's calculate out. 6.9 divided by tangent 54. Okay, 5.0131, so 5.01 cm. Okay, so that'll be the answer. Okay, last part, find angle DEF. So angle DEF is an angle in the big triangle. Okay, so we are going to use info from the big triangle. Okay, so once again, we can use trigo ratio. We know two sides and it's a right angle triangle. Okay, so same thing, if I erase away all the other details. Now, if the angle that we want to find is over here, then 6.9 is the opposite and 15.3 would be the hypotenuse. So O and H. So we are going to use so. Okay, so let's do it. So sine angle DEF will be equals to opposite over hypotenuse. Right, so remember if you want to find the angle, we'll need to utilize the sine inverse function. Okay, so we should be able to calculate sine inverse 6.9 over 15.3. Okay, then sine inverse. Okay, that will give me 26.807 degrees. So for anything in degrees, we round to one decimal place. So the answer will be 26.8 degrees. All right. Okay, so do practice more questions about this topic. Trigo ratio and Pythagoras theorem, generally not too difficult. Okay, so always find the right angle triangle. Identify the angle that we are interested in for the question. Label the sides, whether is it OA or H, and then select the relevant trigo ratio and apply for that question. All right.